In the last video, we have discussed about the equilibrium constant, and we have discussed about the types of equilibrium constant on the basis of concentration and partial pressure. Here in this video, we will be relating the Kp and Kc, and I have taken a sample reaction, and the Kc comes to dE concentration respectively divided by the A, and I've put in a 2 power above the concentration of A. So this implies the moles basically, and I've not taken the B and C, the concentration of B and C, right? So the reason is that liquid and solid, if you see the concentration, their concentration remains constant throughout the equilibrium, right? This is because that their density seems to be constant. Density seems to be constant, and overall you take one concentration as suppose this is for B and for C it is 1. So overall it becomes D concentration multiplied by E concentration, active masses respectively, and this. When you try to write Kp equation for this, so you know that PV is equals to nRT, and by this equation you can write the partial pressures as CRT. So here I am writing it as C concentration of D into RT multiplied by C concentration of E, RT, and Ca concentration RT square. When we see this equation, you can write it as CD multiplied by CE, right, and RT 1 plus 1 divided by CA respectively, and you can write it as minus 2 because this RT goes upwards, and this is the concentration basically, so you can write it as D. So here you can see this becomes Kc, so you can write it as Kp is equals to Kc multiplied by RT, and the moles are getting cancelled, so you can write it as delta Ng because you are taking gaseous components basically, and this Ng implies that moles of product minus moles of reactant, so you can write it as KcRT delta Ng. This is the relation between Kp and Kc,